All right, so before you guys are able to balance chemical equations, you need to be able to count how many atoms are in a single compound. And while it may be easy at first, there are some tricky parts to this. So if you are just watching this, if there are any questions that you have while we're going through it, just stop it and ask. Or maybe at the end, if there's big questions that you have, again, just ask. So the first key concept is subscripts. Now, we're really good at these. We've already done this before. Okay, we've done this with ionic bonding, creating them, and then also we've done it with naming with covalence. So we should be pretty good with subscripts. So subscripts shouldn't be anything new. So we have a 2 here behind the hydrogen. That means I have 2 hydrogens. And then I don't write the 1, but I could say that there's 1 sulfur because it's implied. We don't write the 1 ever. So what that means is I have 2 hydrogen atoms, 1 sulfur atom. So total in this phrase, I have 3 atoms, okay? 2 from hydrogen, 1 from sulfur. All right, key concept number 2, coefficients. This is new. Coefficients are the big numbers in front. So your coefficients tell you how many of the compound that you have. So my original compound, I only had 2 hydrogens to 1 sulfur. That's the same as before. However, I have 2 of those compounds. So what that means is I have, just like this group, an identical pair. So what I could do is I could either get rid of this 2 and rewrite this one more time, or I could just multiply everything in this group by 2, showing that I have the same exact stuff, just a pair of it. So think of twins, okay, with this identical twin. So that means I have 2 times 2 hydrogen, which gives me 4, and 2 times 1 sulfur, which gives me 2. So total in this entire phrase, I would have 6 atoms. Last thing, sorry, with that one. If there is nothing in front, like you see here, 1 is implied. So we just don't write that 1. All right, key concept number 3, parentheses. This is where it can get tricky. So with parentheses, you got to think math class. So in this example that we have, we're going to have a subscript after the parentheses. Anything inside the parentheses is going to be affected by that subscript. It is just distributive property, and distributive property means multiplication. So barium is unaffected here because it's not in the parentheses, so we only have 1 barium in this phrase. But oxygen is affected, so it's 2 times 1 oxygen because there's only 1 here. So 2 times 1 would give me 2 oxygen. That's what I get here. And then same thing with hydrogen. 2 times 1 hydrogen gives me 2. So total in this phrase, I would have 1 barium, 2 oxygen, 2 hydrogen. So I have 5 total atoms in this phrase. All right, now, again, getting a little bit more tricky. This time, we not only have parentheses, but we also have subscripts inside and outside of the parentheses. Okay, so again, calcium's unaffected because it's not in the parentheses, so we have 3 calcium. Okay, phosphorus is, and phosphorus only has 1, so it's 2 times 1 phosphorus, so we have 2 phosphorus total. And then we have 4 original oxygen, but then we have this 2 out here. So we have to multiply the 2 times 4, which gives me 8. Now, if this is hard for you to do the distributive property, instead of having this 2 out here, get rid of it and just write PO4 twice in parentheses. So it would be CA3, PO4, PO4. And that way you're doing the same thing, and all you have to do is count the atoms that way, if that makes more sense. Now, aluminum, again, unaffected here, so 2 aluminum. Okay, now we're going to distribute the 3 times 1 for sulfur. That gives me 3 sulfur. And then 3 times 4 oxygen, which gives me 12 oxygen. Again, if this distributive property is really just hard for you, get rid of this 3, write SO4 in parentheses, 3 other times, so total of 3 times, and then count up your atoms. That could be a little bit easier for some of you. Maybe not for most, but for some, maybe. All right, so key concept number 5, think math class. Okay, pretty much you're doing everything that you do in math class in here within this concept. So just think math class. Now let's do one more example to put it all together, because this is what you're going to do in your practice by yourself. So how many compounds are there? So when I ask that question, I'm looking for the coefficient out here. There's actually 2 because there's a number here. Again, if there was no number, we would just assume it's 1, but there's 2 compounds. How many Pb atoms, which are lead atoms, are there? So in this entire phrase, there are 2 lead atoms because you have 1 right here implied. So 2 times 1 gives me my 2. How many nitrogen atoms? Well, we have to do 2 steps here. Nitrogen's in the parentheses. So just like order of operations, we do parentheses first. 4 times 1, which gives me 4, but I have 2 of these. So I double everything, and that gives me 8. So I have 8 nitrogen. Okay, how many oxygen? Same thing, 4 times 3, which gives me 12. So in one compound, I have 12. But since I have 2 of them, I have 24. How many atoms are in one compound? Well, this time I would just cover up the 2. And that means if I count, I have 1 lead, 4 nitrogen because I distributed in, and 12 oxygen because I distributed. That gives me 17. And then how many atoms are there in this entire? I can do it 2 ways. I already know in one phrase we have, or in one compound we have 17, and I know that there's 2 of those, so I can do 2 times 17. Or what I could do is I could add up all the individuals. So 2 times your PB, which is 2. Actually, I can go down here. I have 2 PBs, 8 N's, and 24 O's. So 10 plus 24 would give me my 34. All right, so at this point, you guys should be ready to practice. If you need help or if you need me to show you some other pointers like I was talking about at the parentheses, let me know. Good luck.